Hi, it's Professor Adam. Let's talk about solutions. Pure substances, be they solid, liquid, or gases, will always only be comprised of one species. These pure substances, no matter what phase they are in, contain only one species. If, for example, copper chloride is mixed with water to form one homogeneous phase, a solution has been formed. A solution is a homogeneous mixture of two or more substances in one phase. On an atomic level, the environment of copper chloride changes when added to water. Initially, when it is a pure solid, the copper and chloride ions are neatly stacked in a repeating lattice. But after dissolving in water, the copper and chloride ions are separated or dissociated from one another and are surrounded by water or solvent molecules. The major component in a solution, such as water in our water-copper chloride system, is called the solvent. The minor components are called solutes. But remember, while most solutions we will consider are liquids, gas phase and solid phase solutions exist too. These keep the same solute-solvent definitions. A solution is said to be saturated when the maximum concentration of solute has been reached. If more solute is added, it will not increase the concentration of solute in the solvent. In the aqueous copper chloride example, if the salt is continuously added, eventually it will stop dissolving and the solvent is said to be saturated. This is an example of a dynamic equilibrium because the speed or rate at which the salt dissolves is the same as the rate at which it precipitates. The processes don't stop. An unsaturated solution is any concentration less than the saturated concentration. When mixing liquids, if they can be mixed in any ratio or proportion, then they are said to be miscible. Conversely, immiscible liquids do not fully mix and will form two separate layers, much like oil and water. Oil and water, when mixed, do not form one phase even when agitated. Some water does dissolve in the oil, which increases the volume of this layer, but the saturation point is quickly reached. When studying solutions, a question quickly arises: which solutes will dissolve in a particular solvent? In general, substances can be broken down into two general types, polar and nonpolar, with ionic compounds being a form of highly polarized molecule. This leads to the adage, like species dissolve like. Polar solvents will usually dissolve polar solutes, but nonpolar will usually not, and vice versa. Basis for this adage, like dissolves like. The main factors are enthalpy and entropy. Entropy is usually the dominant factor due to the drive to disperse energy. The enthalpy of solution is usually driven by the intermolecular forces between the particles. It can be assessed based on the intermolecular forces of the solute and solvent before mixing. For example, in water and methanol, the main intermolecular forces are hydrogen bonds, and after mixing, hydrogen bonding is still the most important, and thus the enthalpy change is expected to be minimal. To further understand the solvation process, let's look at how the energetics work with the ionic compound potassium fluoride KF dissolving in water. To do this, we will use a modified Born-Haber type diagram. Before the ions can be dissociated in water, they must first be separated by supplying energy to break the strong attractive forces of the alternating ions in the lattice. This is usually endothermic. After the ions have been separated, they can be surrounded by water molecules, which is an attractive force. There is a net release of energy, as this is an exothermic process. The overall result of these two steps gives the enthalpy of solution. If the enthalpy of solution is strongly endothermic, then the compound is likely to be insoluble. Otherwise, it likely dissolves in water. This is because entropy is still the dominant driving force. The intermolecular forces of salt dissolution in water can be summarized here for potassium fluoride. The Coulombic or ion-ion interactions defined by delta H lattice between the potassium and fluoride ions is the dominant force that needs to be overcome to dissolve the solute in the solvent. There are also the intermolecular forces of the solvent with itself. In this case, water has both hydrogen bonding and dipole-dipole interactions. The ion-dipole interactions between the solvent and solute are important because these must overcome the ion-ion interactions in order to dissolve the solute. Acetonitrile is a common solvent that has dipole-dipole interactions but no hydrogen bonding capabilities. Let's check comprehension.